Hi everyone, good morning again. Good morning to you all. Welcome back to school, GS3. How you guys doing? My children, well done. Hope you guys have been good. Hope you have been helping your parents out at home. Hope you've not been disturbing them. All these Rokiba 1, 2, and 3, and Biodun, Basit. Hope you guys are fine. Mr. Hampton, all my boys, all 3 rows. I greet you guys all. Well done. Okay, so it is time to study, and so far, since you guys have been at home, the school has worked around ways to get information to you so that you guys don't stop learning. You continue to learn, you don't stop learning, you learn as much as you can. So, and that is why we have this platform today. So basically, I'll just say you guys are welcome to today's maths class. You guys are going to be having some series of classes online. You get, and I believe that you've all been following the trend online since Monday. Today, yes, Monday. Good. So today we're going to be taking I'm going to be taking your math class online. So you guys should have your pen and your books, your notebooks, all these things. They are notes that I would require you guys to submit at the end of, by the time we resume, because we'll be marking them. So get your notebooks and your pen because you're going to be writing. Good. So resuming this term, last time we covered some few topics. We covered simultaneous linear equations. We covered um, similar shapes. We covered which other ones again? Trigonometry, yes, right? As the tangent of 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 a triangle, of an angle rather, the sine of an angle, the cosine of an angle, right? We talked about what else? Areas of plane shapes. Yes. How many of you enjoyed those topics and those word problems I gave you guys and the questions? You guys should really study. Remember that you've not finished your exam from last time, so remember everything I taught you. So you need to study again. Remember those things. Don't worry. We'll take time to do some revision as well. So as much as possible on your own study, because I'll be giving you classworks and I'll also give you assignments. So you solve and then you submit immediately online. You can take a picture of whatever you solve from your notebook, or you can type it online and send it to the WhatsApp group. All right, good. So basically, uh, before we continue with the class, I would like us to do something. I would like us to give a shout out to proprietor and proprietress and the rest of the teachers as well for working together to make this possible. Thank the proprietor for giving us the resources we need, and proprietress as well for giving us the resources we need in setting up this online classes for you guys. I believe you guys appreciate what they are doing, and I believe you appreciate what your teachers are doing as well, because your teachers are trying and they are making sure that you guys continue to learn and you don't stop learning, because when you stop learning you are missing out on so many things. And remember, your BESE exam, your BESE is coming up very soon. I believe it's going to be after the whole lockdown issue. So I believe you guys should continue to prepare, and that is part of the reasons why we're having these classes. All right. So mathematics class, welcome to this mathematics class. I would like you guys to move on. So this term we're going to be starting with something very interesting. I believe you guys started some bit of construction last time as well, but we would have time to go over that again some other time. But starting with this term, third term now, we have in your scheme of work measures of central tendency. I'd like you guys to write this down in your notebooks. Third term work has started. Measures of central tendency, and that's what we're going to be starting with this term, and I would like you guys to follow everything completely. Now, this is an introduction to the subject. You also write this down too. You see, a measure of central tendency is a single value that attempts to describe a set of data. That is, when you want to talk about what a measure of central tendency is, a measure of central tendency is a particular value that describes a group of data. You see, by defining the central position within that set of data. You see, that value is used to determine a central position within a group of data. If you have a group of 10 data, a measure of central tendency will help you to determine a central position within those group of 10 that group of 10 information in that data. Do you get it now? Good. So now, as such, measures of central tendency are sometimes called measures of central location. Do you see now? Like I explained, you see, that's what they are meant for. You see, and I need you to take note of some very important things. You know, it's a single value. Do you see now? From the first definition, it attempts to describe a set of data. Do you see now? Do you get it now? By identifying, make sure you notice these things, the central position that is within that set of data. As such, measures of central tendency are sometimes they call them what? Measures of central location. Do you see that now? Let me take that clearly. Measures of central location. They are also classed as a summary called statistics. In the university, they call this thing statistics. In your higher secondary school, in your higher secondary class, you'll be dealing with some bit of statistics, which also talks about some of these measures of central tendency, of which you'll be dealing on a higher set of group data by that time. But at this point, we'll be talking about just the basic things around these measures of central tendency. Now, the mean. Now, some of these measures of central tendency. One of them is the mean, which we often call average. You see, the mean. We often call it what? The average. Now, this average is most likely the measure of central tendency that you all must be familiar with. But I believe that you guys are smart. You also know the median. You also know the mode, right? Good. You know median. Do you see now? And we also know what? Mode. Good. So let's move on and see what to do. Now, you see, median, or average as it is called, is the most popular and well-known measure of central tendency from your JSS 1 and 2. Do you remember? Because it can be used to with both discrete and continuous data. What does this mean, discrete and continuous data? What does discrete and continuous data mean? Do you all know what it means? When you talk about discrete data, it means data that is defined. It is limited and defined. But continuous data is not limited. Do you get it now? It is undefined. Let me not say it's undefined, but it is not limited by a particular group of it's not limited by any particular group, but discrete can be limited by a particular group. Do you get it now? Although it's also used and most often with continuous data. Do you see now? And when we see our types of variable guide for data types, now those ones are that's from the textbook where it is gotten. Now, you see, the mean is equal to the sum of all the data set divided by the number of values in the data set. That is the sum of all the let's say you have 10 values now in a particular data set. You see now, it says the sum of all of them will now, the mean, it says the mean will be equal to the sum of all of them divided by the number of values that you have. Do you see now? And we are going to be looking at how it is represented now. So if we have n values, that is n, that is the number of values in the set, that then we in a data set, and they have values x1, x2, comma dot xn, that is to the number of values in the what's it called now, in the data set. Imagine we have 10 data sets, like I've been saying. So the first number will be this one, the second number will be this one, third number, fifth, fourth number, fifth number, sixth number, seventh number, till you get to the 10th number. Do you get it now? So now that's how to indicate the what's it called now, the when you number them, that's how the x stands for. It can be any number there, you get. So all of them follow each other in that particular set. Now you usually denote it as what? How do we? The formula is this thing you see here. This is summation x n. Do you see now? All over n. Do you get this now? That is the formula for the mean of what's it called now, of a particular set of numbers. That is the summation. You see this thing that looks like 3 that we wrote backwards, that thing is called summation. It's a sign that represents sum. Now you see that this formula is usually written in a slightly different manner, using the Greek capital letter pronounced as sigma. You see, that's this one that you see here. Do you see now? That's the same, this thing, summation x n over what? N. Do you get it now? That's the total number of values in that set of data. Do you get it now? That's the summation of, that's the sum of all these things. They are sum all over the number of values that we have in that set of data. Good. Moving on. You may have noticed that they are both formulas referred to the simple mean. So why have we called it a sample mean rather? Sample mean. This is because in statistics, samples and populations have very different meanings, and these differences are very important, even if in the case of the mean they are calculated in the same way. What does this mean? This tells you that sample data. Now when you talk about sample data and population data, sample data is just talking about maybe just a group of data. You get now, maybe a group of people, the data about them is what you just quickly do inside that place. But when you're talking about population data, you're talking about a data that involves various groups of people. Do you get it now? Various groups of people, and you now want to find the mean of all of them together. That is what population mean. Do you get it now? Means rather. That's what the population is. That's why they are different. When you're talking about sample mean, it's just within a group of people, just a group, one group. But population covers more than one group. Do you get it now? So to acknowledge that we are calculating the population mean and not the sample mean, we use the Greek lowercase mu. Now it's pronounced as mu, denoted as this sign that you can see here. How many of you remember when we were dealing with angles, when we were solving questions in angles? Remember where we got to one of those angles indicated as this one. So I believe you are familiar with it, and it is written as this: the summation of of the numbers, sorry, let me write that properly. Now as the summation mu, do you see that now, of what, xn all over what, n. Do you get it now? Or you can say sorry, that's the population number, the mu again. Do you get it now? So that's how it is done. And then the mean is essentially a model of your data set. That is, it helps you to view your it's the way to see how good your data set is. How will I put this now? The modeling of your data set is to check the basically, because it calculates the average. So for example, now if you are checking for the average of scores in JSS 3 class, now when you add everything together and divide by the number of students, you see now the average that you get determines how good the data is, how good you have performed or how badly you have performed. Do you get it now? It's just as simple as that. It is the value that is most common. Now that's the mean, is the most common value. You will notice, however, that the mean is not often one of the actual values that you have observed in your data set. That's not the only thing to take note of. However, one of the important properties is that it minimizes error in the prediction of any one value of your data set. Do you see that now? It helps you to minimize mistakes when you are trying to find a particular value in your data set. Now, that is, it is the value that produces the lowest amount of error from all other values in the data set. Do you see now? If you have 10 sets of data now and we say what is the average, instead of just looking for which one is in the middle of them, the mean helps you to give a accurate answer. Do you see now? Instead of just looking for the one that falls in the middle of all of them, and then you now find, and then say maybe you have 1 2 3 4 5 6 7 8 9 10, and then you now say the average will be 5. Do you see now? It will be wrong. Do you see now? Or if you say the average will be 6, it will be wrong, because you are not sure. By the time you add all of them now together, 10 plus 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1. If we even do an example now, for example, 10 plus 9 is 19, 8 plus 7 is 15. So 19 plus 15, we have what? That's 34. Plus 6, that's 40. Plus 5, 45. Plus what else now? Plus 4, 49. Plus 3, 52. Plus 2, 54. Plus 1, 53. Now divide that by the 10 numbers that you have mentioned. That's 5.3. So if you are saying that the average of numbers from 1 to 10 is 5 or 6, you see that you are wrong. There is an error, and the error is, the answer is supposed to be 5.3. You see that 0.3 is also important. It's an important value. Do you get it now? So that's just how it is done. So moving on. Now, when do we not use mean? Mean has one disadvantage actually, and that's just the major thing. It's practically susceptible to influence the outliers. That is, these values are unusual compared to the rest of data sets by being especially small or large in numerical value. Now, for example, consider the wages of the staff in the factory. Now, look at this. Now we are looking at this. Now, what this means is, if you are calculating the disadvantage in this case is that sometimes when the values, when most of the students score low mark, and you now calculate the mean, and then you are seeing the mean is maybe very low, you now tend to feel like, wow, this thing, or maybe the mean is high, then you believe that, and since the average is high, that means everybody got something, scored something correct. Do you get it now? But if the if everybody scored high score, had high marks, and then maybe most people score 70 something, and then the rest scored 90 something, and then you now do the average and you get the average of 80 something, you believe that the average most people would have scored 80 something, whereas you won't know the actual places where there is problem, or where the thing is actually best. Now look at this example of 10 different staff members, people working in a particular organization. Now one person is collecting 15,000, another person is collecting 18,000, another person is collecting 16,000 per year, and all of them, their value, the amount they are collecting every year. You see that the lowest person collecting money there is collecting 12,000 per year, and the person collecting the highest is collecting 90,000 per year. Do you see that now? So now look at this: 90k per year, 12k per year. Now you see that by the time we calculate the mean, now we do the sum of all of them and divide it by the number of workers, and that's what? 10. Do you see now? So and the sum of all of them is 307 divided by 10, we have 30.7 thousand dollars. Now look at what you need to notice about this. Now this is an example that I believe you guys have seen how to use the mean, right? Now look at something. The mean salary of these 10 staff is what? 30.7 thousand dollars. Now says, however, when you look at the raw data itself, when you look at this data that is here, all of them, when you look at this information here, you find out that the mean value might not be the best way to accurately reflect the typical salary of a worker, because you believe that most of the workers are earning $30.7 thousand dollars. Do you see now? Whereas most of the workers, if you look at it, you see that the most of them are collecting from 17,000 to 15,000. That's from the lowest, which is 12, to the last lowest, which is 18. Only two people are collecting 90,000 and 95,000. You see now? So you to make it to really know that some people are actually collecting something very, very small. You see, the mean here would be 30.7 thousand. Do you see that now? Whereas there are some people collecting 90, 95, and all you can see is just that you see that most workers have salaries in the range of 12,000 to 18,000. You see that now? Now the mean is being skewed by just only two large salaries. The reason why you have this is because only two people had this thing. You see, those people that have high money, you see now, it is because of their own that this mean is actually showing 30.7 thousand. Do you see now? So therefore it is in this situation we would like to have a better measure of central tendency, as we will find out later, by taking the median, which would be a better measure of central tendency in this situation. That is, in a situation like this where a lot of people have low, like for example, like the example I gave before in with scores, where a lot of people have low scores and maybe just one person or maybe just two persons have high mark. So the median will help us to better understand the average in the class, or the mode, for example, will help us understand àwọn people he fail gone, or àwọn people these people actually scored very well. Do you see now? So that's just the basic thing about it. So moving on to median, and I think this is where we're going to close for today. Now, introduction. Now, the median is the middle score for a set of data that has been arranged in order of magnitude. What does this mean? It means that in in a particular group of data, if they give you a group of data now and they say find the median, that is in an order of magnitude, that is in ascending order, that is where you can find the median of the group of data. Do you see now? Do you all remember in ascending order that I taught you guys, and in descending order? Good. So now the median is less affected by outliers and skewed data. That is, in the case of where something is too low or some places are too high. Now, in order to calculate the median, suppose we have data information, the data below. Now look at this group of data. How many are there? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Do you see that now? 11. Good. Now, for this case, now look at this. Now we have 14, 35. Now we first need to rearrange the data into order of what? Magnitude. Into what? Order of magnitude. That is from the smallest to the highest. 14 is the smallest number in this group of data, so we start with 14 and then we'll continue like that till we get to the highest number, which is what? 92. Now take a look at this. Now in this case, our median is going to be what? 56. Why? Because it is the one that is, sorry, not this one, this 56. Yeah, that's the 56. Because if you look at it on both sides, you have the median is the number in the middle. You see now, we have 1, 2, 3, 4, 5 on the left. We have 1, 2, 3, 4, 5 on the right. Do you see that now? So that is the number in the middle of the group of letters, of numbers, when you arrange them from the smallest to the highest. Now our median mark is the middle mark. In this case, it is what? 56. Do you see that now? In that group of data, which is highlighted down at that place, in this middle mark, because there are 5 scores before it and 5 scores after it. Do you see what I was telling you the other time? There are 5 scores before it and there are 5 scores after it. Do you see that now? Good. So this works fine when you have an odd number of scores. Take note of this, odd number of scores. Now median is easy to calculate in this method, using this what's it called now, this middle guy, the guy in the middle, the number in the middle. It is easy to calculate it like that, especially when we are using odd numbers. But what happens when you are now using even numbers? When you are given a group of numbers and then when you count all of them, the total numbers is an even number. You know, the first one, we have 11 numbers, right? We had 11 numbers when we counted it. But now, what if we have 10 of them? How do we work around it? You know, you cannot actually know the middle point of 10. But how do we do this? Now, you just simply have to take the two. Now, look at this. You have to take the middle 2 scores and average the result. What does this mean? You see that now. Look at what it means now. Look at, we have, in this case now, we have 10 numbers. Now we have removed that 92. Now, for example, we have removed that 92 and we say, okay, let us, that remains 10 numbers. So let's check the median now. So we arrange. Now the first thing we do is, as usual for median, we arrange the number in order of magnitude. We arrange it from the smallest to the highest. Do you see that now? The smallest number is 14. The highest number is what? 89. Where is 89? Good. 89 is here, and that's 89 here. 14. Do you see now? Now in this case, there are just we only have to take the 5th and the 6th score in our data set, because those are the numbers that we find in the middle. You have 4 scores before it and you have 4 after it. Do you see that now? You have 4 after it. Do you see that now? So now, and then we average them. What does this mean? We pick the two of them and we do plus, and then divide by, sorry, and then we divide it by 2. That is, we add 55 and 56 together, and then we divide by 2. So when we add 55 and 56 together, what do we get? We have 100 and what? 100, I guess 111. Do you see that now? So when you divide it by 2, divide by 2, rather, you have what? 55.5. Is that clear now? So that is that about that. So thank you for following this class. Once again, I say welcome back to school. See you all in the next class. Goodbye.